So imagine this. You're a scientist, and someone tells you the cure for obesity might be hiding inside a lizard. You'd probably think that they had been in the lab for way too long, but that's exactly what happened. And it's actually only one thread in the story of GLP-1 drugs and the scientists who made it all possible. Our story starts in 1902 England. Two British physiologists, William Bayliss and Ernest Starling, discover that the gut secretes chemical messengers, hormones, that passive-aggressively tell distant organs what to do. Fast forward to the 1960s. Researchers noticed something peculiar. If you swallow glucose, your body pumps out more insulin than if you inject glucose into your veins. Something in the gut is turbocharging insulin production. They call it the incretin effect. Very catchy, mysterious, and annoying to ice cream lovers everywhere. Scientists spend the next 2 decades trying to track down this magical gut factor. Enter Joel Habener, an endocrinologist at Massachusetts General Hospital. Habener has a slightly unconventional approach. He studies fish, specifically anglerfish. Why? Well, it's not because he is pescatarian. It's likely because the insulin-producing cells are easier to isolate from fish. Habener's team clones the glucagon gene and discovers it encodes not just glucagon, but several other mystery peptides. This is where Svetlana Moisov, a chemist, comes into the picture. She arrives at Mass Gen in 1983, sees the glucagon gene paper, and has a light bulb moment. She notices a conserved cleavage site in one of these mystery peptides and hypothesizes that the real active hormone isn't the full GLP-1, it's a shorter version. She synthesizes it, she tests it, and in early 1987, Moisov, along with Gordon Weir and Habener, shows that truncated GLP-1 significantly stimulates insulin secretion. The full-length version? Nothing. That same year, Daniel Drucker, a young Canadian endocrinologist in Habener's lab, demonstrates that truncated GLP-1 stimulates insulin gene expression in a glucose-dependent manner. One day, Drucker walks into the lab and his notebooks are gone. Eaten by a goat? Nope. His supervisor, Habener, had taken them. He was excited enough to file a patent. Take note, everyone. Meanwhile, Jens Juul Holst, a physiologist at the University of Copenhagen, confirms that the truncated GLP-1 is present in pig intestine and stimulates insulin secretion. Holst, with Carolyn Deacon, identifies DPP-4 as the enzyme that chews up GLP-1 in the bloodstream, giving it a half-life of just 1 to 2 minutes. So we've got this beautiful hormone. It does everything you'd want. Boosts insulin, suppresses glucagon, slows gastric emptying, makes you feel full. But it disappears from the blood faster than your motivation on the 2nd of January. The solution came from John Eng, a researcher that was doing something wonderfully eccentric, screening lizards for bioactive peptides. He'd noticed that GLP-1 and other gut peptides shared common properties, so he went looking for lizard venom peptides with the same feature. In 1992, he found one, Exindin-4, from the Gila monster. It looked a lot like GLP-1, bound to the same receptor, stimulated insulin secretion, but was missing the key feature that makes native GLP-1 such easy prey for DPP-4. That single difference gave Exindin-4 a half-life of about 2.4 hours, about the length of a Peter Jackson movie. Drucker, now back at the University of Toronto, picks up this thread. He gets hold of a Gila monster, presumably by the tail, clones the Exindin-4 gene, and confirms that it was active at the GLP-1 receptor. Meanwhile, Eng partners with Amylin Pharmaceuticals to make exenatide. Clinical trials show it modestly lowers blood glucose levels and results in weight loss. On April 28, 2005, the FDA approves exenatide as Byetta, the first GLP-1 receptor agonist ever to hit the shelves. Hold on to your hats. That wasn't the only IP action. In 1990, Mass Gen files patents on the therapeutic use of GLP-1, listing Habener as the sole inventor. Moisov, whose experiments were central to the work, isn't named. During a casual conversation with a biotech company, she is outraged to find out about the granted patents. At a 1993 conference, she confronts Habener. His response? He says nothing and walks away. What follows is a grueling legal battle. Moisov hires lawyers and spends over a decade fighting to be recognized as a co-inventor. The U.S. Patent Patent Office eventually corrects the mass-gen patents, and Moisov receives her share of royalties. Poor Drucker. His data was also in those patents, but he simply laments not pursuing acknowledgement. Like many scientists, gratitude to his supervisor for shaping his career led him to let it go. Recognition was something that Novo Nordisk never had to fight for, thanks to the rainmaker Lotte Bjerre Knudsen. Knudsen, a pharmaceutical scientist, joins Novo in the early 1990s, and by 1995, she leads a small team aiming to turn GLP-1 into a drug. From the start, Knudsen believes this won't just treat diabetes, it'll treat obesity too, a bold claim for the time. Her team's approach is elegant. Attach a fatty acid to the peptide so it hitchhikes on albumin in the blood, protecting it from degradation and kidney filtration. They test hundreds of combinations. The result is liraglutide, with a half-life of 13 hours and approved by the FDA in 2010. Knudsen's team then further engineers semaglutide, a long fatty acid hydrophilic linker with a mutation blocking DPP-4 cleavage, giving it a half-life of 7 days. The one injection per week Ozempic. Novo's blockbuster drug generates over $26 billion in annual revenue, and with US patent rights until 2032. Today, GLP-1 drugs have become a global phenomenon. The research was all generated by diverse scientists, with different skill sets focused on a century-long puzzle, leading to the first truly effective medicines for obesity, with implications for heart disease, kidney disease, neurodegeneration, and more. Not bad for something discovered from a lizard and fish. Thanks for watching, and as always, keep imagining.